So the speaker is Mr. Luke Lee. He's the current president of Korea, Taiwan, and South Asia of TI. And he will give the talk of extending the benefit of a gallium nitride solution from power delivery to other industrial applications. Let's welcome Luke.
Thank you. Good morning, everyone. I love to come back to SEMICON Taiwan. SEMICON Taiwan pushed me back to a very old memory because of my first job was a semiconductor equipment engineer. So SEMICON Taiwan is the most important event for semiconductor equipment engineer because we need to prepare all the show demonstration, right? So SEMICON Taiwan connecting my memory is there is no Hmong festival because of SEMICON Taiwan always come together with a Hmong festival or close by. So which means we need to sacrifice our holiday for demonstration preparation. So which means the memory for SEMICON Taiwan containing, well, busy and no holiday. But it's not point today. But it's also talking about a new material in 1997, right? We talk about a low-K material because of the transition from the 13 nanometer to 65 nanometer require copper. So copper need the low-K material for the innovation. Then several years later, we are talking about a high K because of 28 nanometer require high K material. And today, everyone are talking about the wide-bandgap semiconductor, right? So today I would like to share to you is we are more ready for the gallium nitride because of we have a significant improvement and progress in the power delivery, the end equipment, and we are pushing all the success story to next other end equipment. So I would like to share to you today. So before I get started, I would like to show TI. TI is a company, we have analog and embedded processor product. We have a wide product portfolio from the small, like ESD protector, USB protector, and also biggest data converter or like high-speed semiconductor. And also we have a processor, MCU, connectivity. So we have a wide product portfolio to cover 5 market segments, including the auto, industrial, PE, com, and enterprise. And also we are using 80,000 products to service 100,000 customers in the worldwide. 80,000 products to service 100,000 customers in the worldwide. Through direct channel, which is local office sales and FA to support customer, which give us more transparency. The relationship with customer, and I will talk about, is help us understand their demand for the long run, so make our long-term investment will be more critical. And also we have 24 hours digital channel, ti.com, which allow customer to access every TI data sheet, white paper, and also the solution through the website. And also if you need to have any EVM or small quantity order or urgent demand of your order, you can purchase it from the TI store, which allows us, give you a non-stop service. And also we have a E2E forum, give you a 24 hours response in any situation, anytime. So both of the direct channel allow us to build up the direct relationship with customer, and also we have our distributor area to help us service the customer as well. Right, so that is really critical. So I just would like to share with everyone. So let's talk about the investment. Yeah, as I mentioned, when we have the relationship with more customers, we just realized that the long-term growth opportunity is really amazing. So we made a huge investment. Those 6 new wafer fab will kick in the next several years, and which allow us to produce a more analog power device and analog signal chain, which is pretty much a legacy device, and produce from the 40 to 130 nanometer, so which is really help us customer to give them more flexibility. But in the meanwhile, we would like to partnership with our external manufacturer partner, right? Because rumor has it, when TI have our own fab, then we will give up and turn down our business with external manufacturer. It's not correct because of we are partner. So I appreciate our competitor don't talk about that to break our relationship with external partner. Okay, thanks. And also that is very critical. When we have a huge investment in this space, we also will push our gallium nitride manufacture line to push more, and also with further cost reduction and yield rate improvement. So that gives us more essential property to really support customers' long-term success. All right, and also we don't leave assembly alone because of assembly and the test showing very critical. I will show you later on because of today most of wide-bandgap semiconductor are doing discrete FET only. But in TI, we are doing a highly integration device, and I will show you later on how can MCM, SIP, MCP help us to reduce the total cost. So also we are making a huge expansion in the AT site in the multiple country because of we want to make sure that we have long-term support plan to help customer, and also together with package technology can allow us to bring more innovation. Okay, so let's talk about gallium nitride. The reason why I say it's getting more ready is because of regulation. So if you look at the government regulation, is pushing a high efficiency requirement in the world. So it's giving the supplier a pressure. You have better to produce high efficiency product with small ball size and high density to service your customer. Not only in the server, but also data center, and also all the way to home appliance, TV, adapter, those and equipment. So that is the reason why we say it's getting more ready because of regulation will push the demand move on, right? And also then let us talk about the requirement for semiconductor. I'm talking about semiconductor. So every customer is expecting we need produce the shrinking, the small size, the semiconductor, as small as possible, and also high performance, which allow them to do more, right? And also high reliability, extending to multiple end equipment. Of course, we don't leave the cost alone, right? Because of smart the customer, they want to everything. So question, can gallium nitride meet the entire requirement? Right? So first the question is, how can gallium nitride get small ball size? Yeah, it's simple because of through MCM and multiple chip package, then which allow us to reduce your ball size and also your component size. And also for gallium nitride, we are pushing the performance forward. So I will show you later on for more detail. And reliability is the same thing, together with yield rate, and also how can we make improvement on the system performance, right? So lastly is the cost. Yeah, I have a high confidence we always can make the best cost from the component and system level, and we will show you later. So that is the expectation from the customer. So here I just would like to give you the idea, the power delivery application now is adopting gallium nitride. So you can see that many are focused in server, data center, the cloud, high computing power, right? So telecom power, good, that is good enough. Everybody knows that. But we also can see the better pack, the end equipment. We also can use that. I will show you the case later on. And also UPS is very important, right? UPS, the inverter, and also all those design require very high efficiency, so that is a good place. And also industrial power, I also have a case to show you today. And the consumer AC/DC power supply, that is also area we see the quite success, but I also have the adapter case we'll show you today. So that is the area why we foresee the gallium nitride will be success in the near future. It's because of the key trend and opportunity is pushing all the customer. You have no choice. You got to migrate to the gallium nitride as soon as possible. Because of today, most of cloud customer is pushing on the high power density. Every time when I talk, then they push up the power density in the same space, even in a small space. They want to more power density. Efficiency. From 91 to 93, push up to 97? No, it's not good enough. They want to push more, right? Good, I like it. And ensure dual sourcing because of they want to make sure that there is no big shortage when the demand comes up because of power delivery. You can consider about that is high run rate business, right? And also titanium grade is back to that kind of requirement. And also there are many interfaces in between the protocol. So the member they would like to communicate and real-time monitor on the power supply status. So everything is pushing the power delivery to more and better world and how can supplier to meet that requirement. So challenge have three. So first one is from topology. Topology will migrate from the traditional bridge. I will show you later on, so I'll skip this. And also hardware. Hardware is because of gallium nitride is a new material, so there are many engineers are afraid they are not familiar with this new material and they just don't understand about how the use case. And from the system level, there is a EMI challenge and thermal, right? And also because of a high switch in the frequency, it will cause how can we doing a better job for the firmware, right? So that is top three challenge, and that does address one by one. We already been fixed everything. So from the topology change, you can see from the bridge, the topology require fire diode, right? So you can see the very big power loss in that space. Then the transition to the totem pole PFC is bridgeless. The two switch, which the one diode allow us to do, very high speed switch and also reduce all the loss from the diode. So that gives us all the benefit, right? But the question is, how can we, implement this topology and all the system design? So I will show you later on. We have tons of solution in the ti.com. You can download anytime. It's including Gerber and simulation and everything you want to qualify your system. You just do this like this, okay? I'm sorry, it's not that easy, but very close. Okay, so that is our goal because we don't want to iron the spend of your time just doing all the tests. We want to save your time. So if you have any wish target equipment, just go ti.com, click. I will show you the link later on, and you will see all the good reference design and solution. It's amazing. And also, our GaN solution, we are doing all-in-one. So we put the driver and the FET together. Let's give my TMG, our manufacturer line team member, hard time because of you got to put everything together. It's not easy, right? With a high yield rate, but it's a significant fix all the placement and also layout issue, right? So that is amazing. And also we have more better design, so magnetic component can be reduced more than 60%, so which allow you to produce a system which is small both sides, right? And also, most important is the reliability because of people is worrying about the short through, right? So we fix that issue as well. And also, a lot of people ask, hey, look, this is a new material. How can you prove the reliability, right? Yes. Look at that number is 40 million hour, right? Last time my speech is 20 million hour, but now we push forward to 40 million hour. And next time when you see me, probably we can hit the 60 million, right? So that is amazing. We put everything together to solve the challenge And also, we put the real-time controller together to really enable soft switch and providing the soft firmware support and help customer to have a closed-loop control, which allows us sensing the current situation and provide a very precision, adjustment. So that is really tied up. For some of the applications not require real-time MCU control, we also have a very good ACF device, which can allow us to do the shift frequency technology, which allow us to do even high efficiency and also small both size design, so which is really help all the turnkey solution. All right, so I finished power delivery. You can see my excitement, right? Because of we just finished entire of hard work. So now we move, project expansion like crazy because of customer eventually understand, well, it's not bad. It's time. Let's go get started again design because of it can, just like Gary Stevens said, it can make our world better, right? So that is a time greater than we are ready now. So I would like to share about the battery test system, which is a new area we are moving our solution on, with more EV opportunity and also more battery requirement. I just don't understand why we produce so many battery, right? But anyway, that is the situation. So with all those battery, demand incremental, so we need to have really tester equipment. So tester equipment, when we have more battery requirement, then you would require more the AC source in, right? And also you need to have multiple channel to do a DC-DC charge and discharge, right? So GaN allow us to reduce the both sides of AC-DC converter, right? So which allow us to enable more AC source in with a small both size. And also allow us to reduce the transition time of charge and discharge, so which allow us to use some small device to test more battery, right? So that is the reason why we can help the customer to use smallest tester to produce more battery, right? So that is really a very good case study. And also power adapter for the consumer device is everywhere, right? So that is an area we would like to see the design. How can we shrink all the size? So TI solution is a 6-in-1. We put the die into the one package, then which allow our customer to produce a worldwide smallest adapter, which can help a customer really reduce the total BOM cost and both sides. So that is amazing. So you can see how much work we've done internally. We push our manufacturing team like crazy, right? And lastly is the solar and the energy. That is also an area we feel very excited because of traditionally we will have solar converting, right? So when we have a sunshine convert to the power, then you will through the AC DC. So first time you need to have a transition lost. Then from the DC to DC to your battery, then you got to have converting lost as well. So TI bidirection, the technology can allow us to reduce both two sides converting lost. So in order also providing additional protect function in between. So that is we so-called 3-in-1. And in phase level 3, that is amazing. We can really help solar solution to produce with a very small space and with high efficiency from the inverter point of view. That is amazing. So that is the area we also pursuing. So that is, we also have a reference design. Later on I will show you. So this is the latest TI reference design for the power delivery and other industrial application. So you can find all of them from the ti.com. It's public. You can see. You can download. And if you have an interest in, you also can buy it from the TI store. And if you want to buy the sample, you also can buy. And do you know how many people buy this from the TI store? I cannot tell you, but it's a lot. I was so amazing because too many people buy from here. I just realized the people's desire, we would like to make the world better than before. not patient really drives the results different. So lastly, I would like to give you the closing. When you walk out from here, I want you to remember the gallium nitride is more than ready. Please use it. It's easy. It's reliable. Okay? And that is the best opportunity we can save the world and give us the children a better world and their children, right? So that is the goal we are looking for. And also, here again, technology help the system integration and really bring good results together with the customer. And also, our entire team put in all the effort to support our customer. So there is no question. And also, we are using the internal manufacture capability to support GaN, and I personally is driving that and make sure we have reliable capacity and cost efficiency product to support all of our customers. So that is my last takeaway to everyone. So here is all the information what I described today, or I did not describe it today. You can find from the ti.com. So please feel free to take a look, and maybe it can inspire us to have a better idea. Because of, back to Gary, what he mentioned, we need the more people, more suppliers to join this, because of we want to see the more end equipment is using again. So lastly, I would like to say thanks to everyone and Semi, and good luck, stay in safe and stay in healthy. With that, thank you so much.